Okay. So proportionate test is something that nobody does. Okay, something nobody does, but I have to teach it because just to complete. It's coming out only in the OBA. Only in the OBA. And I will teach you how to answer it fast. So when do you use proportionate test? You are conducting a massive trial like vaccination on the population, and you want to see the rate of people who got the disease. Okay. So if you're doing this vaccination, then you are going to use it. Why? Because you got only two variables, dichotomous. Risk factor, vaccinated, not vaccinated. Outcome, got the measles or don't have the measles. Okay. So that is why we use such tests. Okay. Whenever we have humongous data set. Why we are using proportionate test? They're saying that if you have a large enough sample, although it is dichotomous, yes or no, the outcome is like continuous. Okay, binomial distribution, if done on a larger scale, the distribution follows a continuous scale. That's the argument. That's why they use the proportionate test. I know you don't understand what I said just now. Okay, so they have a formula here. Okay, they have a formula. This is the formula. So basically, the concept is you start with the data set, and based on the data set, you calculate the Z value. How to get the Z value? You have to get the PO and QO, and the PO and QO you put into the formula, you get the Z value. Okay, so this one does not make sense. I know it doesn't make sense. When I show you how to calculate, that's where it makes sense. That one does not go into the computer. This one is it's not Star Trek, it's Stat Trek. Star Trek. If you want to do proportionate test, the data should have been selected based on simple random sampling. They should have dichotomous outcome and risk factor. Okay, and they should be large enough to have at least 10 success and 10 failures. Okay, it should be 1/10 of the population. Okay, so for the females, the rate of those who got infected was 29. How many are there? How many guys are there? There were 96. Female, 24. How many female are there? 104. Okay, so now what you do? You minus the values. Okay, to get the total. So you just go this one is 200. This one is 53. So 250 is 147. Okay, so 104 minus 24 is 80. So this one is 67. So now we have this. So which one is worse, male or female? So 29 divided by 96, you get 30.2%. Okay. 24 divided by 104, you get 23.1%. These are the raw percent. Okay. So this is the P1. This is the P2. $53 divided by 200 is 26.5%. This is the PO. Okay. 147 divided by 200 is 73.5%. This is the QO. PO is the rate of those infected. QO is the rate of those not infected. Okay. P1, P2, the rate of infected in population 1, the rate of infected in population 2. Okay. So, rate of success, rate of those infected, 26.5. Rate of failure, rate of those not become infected, 73.5%. Okay. So, you can see there, by doing that, There's no need for me to calculate the PO. Otherwise, I have to calculate the PO. Put in the formula, the P1, the N1, P2, N2, get the N1 and N2. Then you get the value of 0.265. Here already got 0.265. Just based on the table. So what I'm telling you now, exam, prepare the table. Prepare, then immediately you got the answer. You automatically you get the PO, you get the QO. Okay. So QO is 1 minus PO, 0.735. Then you put into the formula PO and QO. Okay. So P1 minus P2. 30.2 minus 23.1. Divided by PO times QO. So PO times QO 0.735 times 0.265. 1 over N1, 1 over N2. Then you square root it. You get the value of 1.1367. And from there, you refer to the table A1. Based on the table A1, 1.1367, 1.14, the value of the P is 0.1271, 0.1271 times 2 becomes 0.2542. So 0.2542 is larger than 0.05. So null hypothesis is not rejected. I repeat back, 0.2542 is larger than 0.05. Null hypothesis not rejected. Okay, and with that, we finish the exercise. Okay, thank you very much.